Well, to just talk local to everyone has a template.
Yes, just as everyone who cares.
No, I think there's a room in San Francisco.
Actually, many people care. Many people don't know enough to care. What's that?
Oh, no, you did talk about last year, didn't you?
We talked about it at the Unicode conference.
So we've got this is an updated version of it, right?
Yeah.
It's slightly updated. Basically, we're doing this to record a date.
That was, everyone knows you like it over here.
I don't know.
No. Everyone was at the summit.
Thanks for coming. Yeah, I didn't even know this was on. I'm glad you sent the reminder.
Yeah. Well, thanks for coming. Not as funny as your type, but
What's that?
not as funny as your type, but.
I'm sure. No, all the fun is from Behdad. If there's any fun, I'm just worrying that you know that.
It's a straight man.
Yep. Too straight.
Okay, I see someone on VC at least. Is Philip?
Yes. So be careful about talking about future products.
She wanted to be here and she was yes. Wait a minute. This is open to the open.
Not well. Yeah, we want to publish it.
We're going to make the recording public. Okay.
I'll tell you.
Yeah, mostly because Unicode Conference doesn't want to make itself useful by doing that. Yeah, that should be Philip. Okay, let's start.
Oh, okay.
Hey, full house. Okay.
Everybody.
Eric, are we good to go?
Ready when you are. Everything's set. Recording started.
Okay. So is the recording on?
Yes.
Okay, let's start. Hello, everyone. Thanks for being here in person and on VC. This is a session Roozbeh and I initially did 6 months ago at the Unicode conference. We wanted to do it again because there have been exciting updates and we wanted to record and publish this. I'm Behdad. This is Roozbeh. We have been working on fonts and Unicode one way or another together for the past 15 years.
Probably even more.
Yeah. But yeah, more officially for the past 15 years. Initially back in Iran, our shared interest was to do Persian in computers. Then we separated, like I went to Canada for studies, ended up at Red Hat working on text rendering and Unicode. Roozbeh ended up at High-Tech Passport, and then we separately ended up at Google, and then I recruited him to Google, he recruited me to the internationalization team, and then he left for Android. So,
It's been a dance.
yeah, so in this session we want to share two stories. My story is the HarfBuzz Indic-Shaper, and I get to what HarfBuzz is and why the Indic-Shaper is interesting. And then Roozbeh will talk about the Noto fonts. And then we have this idea that we try to connect, learn from Unicode, apply it to OpenType, learn from OpenType, apply it to our fonts, and then whatever we learn, push it back to the Unicode standard. And then we talk about how we are trying to close open problems in OpenType, working with other industry members, and then what we learned. So what's with the HarfBuzz Indic-Shaper? Back then, when I was at Red Hat, I was tasked to maintain the index shaping in the Linux desktop. So the Indic-Shaper is the piece of code that takes Unicode text in index and the font and decides what to show on the script. That's what the shaper is.
So basically the input is two things. The input is a string of characters and a font, and the output is basically saying exactly where on the screen each glyph that is supposed to render that string is gonna go for, something like that.
Well, I mean, for me, back 7, 8 years ago, it didn't matter because I didn't know anything about Unicode encoding and shaping. So I had this piece of code in Pango. the Indic shaper in Tango that's responsible for rendering things in GNOME on your Ubuntu machine. And then there was another shaper in ICU that was used by mainly OpenOffice and Java. There was the one in Qt used in KDE. So there was this 3 different implementation of the same idea. And I was the maintainer for the text rendering in Red Hat. And then the internationalization team at Red Hat would file bugs against the Indic shaping and say, this sequence with this file, it works correctly on GNOME, but not OpenOffice and not KDE, and this other sequence works in KDE and OpenOffice, not GNOME. And then I had no clue if it's a shaper bug or font bug, because the fonts were also developed by the Red Hat internationalization team. So that was what I was supposed to do, and I ended up just taking whatever patch the internationalization team had, because they claimed that it fixes it, but I knew in the back of my mind that is introducing like 10 other bugs for other sequences or other files. So, and the existing implementation, at least the Pango and ICU ones, were too magical. And by that I mean it was a state machine, hand-coded, so there was a lot of numbers. And the proper way to fix a bug would have been to add more states to the state machine. But because I didn't understand the state machine and no one else did, no one else at the time, we just kept adding if statements for particular sequences. So in 2007-8, after I joined Google, I had already started rewriting HarfBuzz, which was my grand plan to share the shaping responsibility, to move it into one library that I maintain, and then everyone can use it. So by the time I got to Google, it was time to attack the Indic problem at HarfBuzz. So I started reading about Indic shaping. I read the Unicode chapter on it, and then I read the OpenType chapter on it. The OpenType spec, if you probably didn't have to deal with it, it's a kind of a set of recommendations and high-level spec. It's not nearly detailed enough for a full implementation. But it did have these nice regular expressions. And
just to give you a little more background, the OpenType spec is basically written by the same people in Microsoft who basically maintain their rendering engine. And it's a kind of a documentation forward. And I mean, from what I've understood from talking to the people in charge of it, it's mostly written for font developers, trying to explain how the engine works. So they would kind of write the fonts in some way and then play with the engine and get the right behavior. So there's an assumption that the engine exists, and there's an assumption that you know what you're doing with your font, you know what's supposed to happen, and this is kind of a spec written for them. This is the only public kind of a publicly available documentation on how to do these things.
Okay, so I found that it's a regular expression. I studied computer science, so I just used the right tool to handle the regular expression. So instead of hard coding a state machine, I decided to find the right tool that takes the grammar and generates code for it. I tried 4 or 5 different tools, ended up choosing one called Regel. It's a state machine compiler, and no one else that I know ever heard about it. But it's very nice. I converted this into this piece of code, which, or Regel input, which is a bit more cluttered, but essentially the same regular expression, just grouped differently. So that solved my syllable matching problem. Now, I had to feed data to it. So the grammar on the OpenType spec talks about these character classes, like this is a consonant, this is a vowel, this is a nukta. And then I needed to know for every Unicode Indic character, and when I say Indic character, it's not one script or just 100 characters or so. It's like there are over 10 different Indic scripts in Unicode. Each of them have like 100 characters. So we are talking about like thousands of characters that I don't personally know about, and I can't go just manually try to mark the bit. Fortunately, Unicode also has this data files called the Indic syllabic categories. They look like this. The Indic syllabic category bindu or a nukta. So it was not too hard to map them to the OpenType category. So that's what I did next. And then the OpenType spec has these 4 steps for how the shaping engine works: find base consonant, decompose, reorder, final reorder. Yeah, for each of those, it has like 1 or 2 paragraphs. So that's exactly what I did in my code. So after some filling in the blanks, I had a shaper, but I had no idea how to test it. I had a test suite of about 100 or 200 test cases. I could tweak things and like suddenly 20 of them would pass, but I had no confidence in this because I knew this will fail for any real case scenario. So that's when I had this moment that I figured, because OpenType is so underspecified, by definition, whatever the Windows implementation does is what OpenType is. So my goal is not to try to match what the spec says. My goal is to match Uniscribe, which is the Windows implementation of types.
Yeah, so the spec basically became a kind of a guiding light in some, basically understanding some dark corners. What we found is that the regular expressions that are in the spec are not the same thing that's implemented. A lot of even the character classes are not the same. A lot of things are underspecified. Some things are just like contradictory to what they actually implemented.
So there was no Uniscribe equivalent in other platforms?
So the question was, there was no Uniscribe equivalent in other platforms?
So the free software ones were the 3 implementations that I started maintaining to begin with. There was on Apple platform, Apple used to have their own a smart font technology called AAT, which is different from OpenType. So basically, no. And Adobe had a bit of a joke of an implementation of the Indic-shaper.
Yeah, that's a bit simplification. Adobe has an implementation that's used in products, probably has more than one. We've heard like 2 or 3 implementations that Adobe has. And they're not completely consistent with each other. I think Flash used one. There are various graphical software. InDesign had something. I mean, and because of their technical limitations, they're not the same thing, and they don't match completely in how they render. And they have limitations. For example, I know, for example, that Sinhala, one of the major scripts of Sri Lanka, has been a very important user request for them, but in some of their engines, because of their architecture, they can't even support it.
And Monotype has an implementation in their products, and the Wine emulation layer has another implementation for software, but none of these were nearly as tested and robust as any of the ones I had to start with, like the Penguin ICU. Those were the best alternative implementations of this, but there was a lot to do on top. It's one thing if you test it in one sentence, you write Hindi in Hindi and it renders. It's another thing to actually match Uniscribe on the internet.
The other tricky thing is Microsoft implemented some shaping for Indic because they added some extensions to the OpenType spec that were not at all for the Indic.
Yeah, this is. So the comment was about the OpenType spec and that the Uniscribe engine had more. This is kind of what we found is a lot of especially around the edge cases, there are things that are not documented. So I think Adobe's implementation was mostly based on kind of reading the spec and trying to implement it, and that's how we started too. But then we found out that we cannot rely on the spec.
So what we ended up doing is write these 2 little tools, HPView and HPShape, that take a font and sequence, and HPView renders it. HPShape gives me written information about what the rendering should look like. So for example, in this case, if I use HPView on this Arabic typesetting font, and that sequence in Arabic, I get the image on the right. If I use the HPShape tool, I get this cryptic line of text, which tells me exactly which glyph is rendered and at what position. Now the next step is I added a backend to HarfBuzz to call Uniscribe for shaping. So I could use the same command line to invoke Uniscribe, and then I could compare the results. We actually did the same for Cortex, which is the Mac implementation, and it produces different results sometimes. So with these 2 tools together, I decided that based on my experience at Red Hat and bug fixing all these things, I still wouldn't be confident in the shaper unless I could test pretty much everything that has to go through it. So I came to Roozbeh and Internationalization team. I said, see, I have the shaper and infrastructure to improve it, but I need you to go crawl the entire internet and give me a word list for every language.
So if you could go back to that sentence, this is so true. I've been rediscovering this with all my software engineering career again and again. It's just like this is probably a golden rule that it should be there. We found the same issues with the Noto fonts, for example, and basically anywhere we look, anywhere we test, we find some issues. Then basically, this is kind of I would really recommend that don't trust your proof of the code's sanity unless it's actually tested.
So Roozbeh came back to me a few weeks later and said, hey, I was too lazy to go MapReduce the entire internet, but here's the Wikipedia corpus.
The truth is, I wasn't actually too lazy. The truth was, I figured out that the text on the web is actually too chaotic. So we couldn't necessarily trust anything on the web. What I actually found with my own experience as a Wikipedia editor was that the text on Wikipedia usually goes through some sanity checks. Some people actually see it. So we didn't only restrict this to the actual pages because the pages are a bit cleaner. We also added talk pages, so we bring some kind of crazy text into it. So we would have something like some text that is of high enough quality, but not necessarily only language you would put in kind of formal articles. You would have chatty language, for example, that also covers more of the cases.
So this is using the HP shape, I put together a few tools to prettify my diff. So this is the kind of thing I could get using the corpus from Wikipedia, my shaper and the Uniscribe shaper. So basically, for every language, we had something like 100,000 to 1 million different words. We would sort it by frequency on Wikipedia. Then we would generate the output using Uniscribe backend and my backend. It would take like 10 seconds to generate those and diff it and visualize the difference. This is, for example, this is a very recent output. You see the first word that we disagree with Uniscribe on is at rank 150,000. So when we started, it wasn't like that. It was more like, well, basically, I want to also mention Jonathan Q. He's an OpenType and, well, text and Unicode expert at Mozilla. And we worked on the Indic-like pretty much together by getting together like 1 week every quarter somewhere in the world, sitting down behind one laptop and hacking on this. So the first time we did that, we started with the shaper that I had. For Devanagari, we were failing 35% of the tests, like of this 1 million words. After a week, we had it down to 0.08%. That's only like 560 test cases difference with Uniscribe.
So this is not weighted frequency. This is just like raw frequency. So basically, a lot of that 35%, well, of course, at the bottom.
Yeah.
But then that also tells you that getting to the 0.08% was actually a huge difference. Basically, we were handling now almost everything right.
And we reiterated this a few more times. So this is from July 2012. You see, like, Uriya, for example, had 9 failures, Tamil 0. We have, like, Canada over 1,000, Malayalam over 1,000. We kept reiterating, doing more of these hackfests. We got most things further down. Now you see Bengali and Devanagari went up over time. And the reason is, as we did this, we discovered bugs in Uniscribe, or corner cases that, well, wasn't maybe not quite a bug, but we thought we could do a better job. So we did 2 things to add this out. One, we added a mode to HarfBuzz called Uniscribe bug compatible. So under that mode, we try to emulate the bugs so we get better numbers. But as we keep adding things, some things are harder to just have a bug compatible. So we want to understand the implications, but one would think it's a good idea depart from what you described as.
Yeah, and actually a lot of deliberation goes into that. We actually really make sure we understand the thing right. A lot of these are actually limitations in the original mindset or of the designers of the Uniscribe or the regular expressions there, that they were saying, oh, this sequence can never happen in real life language. And we actually found evidence that it happens and it's valid and it conforms to Unicode and it's actually what users need. So a lot of these things are about the cases, for example, that Microsoft somehow either rejects it or doesn't understand the structure of the syllable right, and we actually understand it better.
Or just plain bugs, and we report those back to the Uniscribe and Microsoft developers. So after we had this done, Microsoft added a Myanmar shaper in Windows 8. We got together based on the infrastructure that we had already set up. We got the new Myanmar spec. We saw that it's different enough from our the Indic model that we need to add a new shaper, but like we had all the infrastructure wired up already, so it was very quick. Like in 1 week, we added the Myanmar 1. Error rate is essentially 0. Then, while at it, we figured that there are some scripts in Southeast Asia, like kind of scripts that are newer to Unicode, that Microsoft doesn't have a shaper for them. No one has a shaper for them. But it's very clear how a shaper should work for them. So we also added something called the Southeast C shaper that handles a bunch of those. Those are mostly simpler than the original Indic shapers because either structurally they're simpler or Unicode learned the lesson and they encoded them in a simplified model. And then again, Windows added a Japanese shaper in Windows 8.1. And same thing. We got together. We figured that we read that one and saw that we can add it to our Indic shaper rather easily. So we just updated the Indic shaper to add Japanese. And this kept going on. Well, after Japanese, we got to a point that we could claim we support all the scripts that Uniscribe supports and then some. So at that point, we thought HarfBuzz is done.
Yeah, so Uniscribe's approach to scripts was basically that they added them one by one. They added, okay, let's go research the Devanagari, figure out stuff. Now let's do Bengali, figure out stuff. Our work of, first of all, building on their work, and then relying on the Unicode, basically, character properties that were very kind of provisional at that time, that the kind of categorization of the Indic characters into the various parts that form the syllable. Based on that, and then based on some extra research, we could actually do much more scripts than the kind of the Windows approach, which are one by one.
Yeah, and that's a main difference between our shaper and Uniscribe, because in our shaper we have one Indic shaper, it's one piece of code, data-driven, handles 11 scripts or 12 scripts, whereas Microsoft, they had a Devanagari one, they made a copy, made modifications for Bengali, made a copy, made modifications for the next one. So they are left with these like tens of shapers, over 10 shapers that they have to maintain, and that's why they don't make any changes to them, because the cost of breaking them is really too high.
Yeah, the cost of testing is high from what I've heard, and basically each of them have different bugs, basically.
So at this point, Jonathan, Mozilla there was this desire that if we have the shaper that is as good as Microsoft, and we are confident in it, and it's our code, we can fix things and turn around things much faster, we want to use it on every platform, on Windows, instead of just on the free software platforms. So to gain the confidence to do that, he started this testing infrastructure on Amazon AWS to test all the languages, all the fonts, all the word lists. And he brought up this thing, dashboard, that gives numbers, and then every time he wants to pull HarfBuzz into Firefox for an update, he reruns the test suite, so he makes sure that we didn't regress RSA. That has been immensely useful. Now, we didn't really, between the two of us, have the time and resources to polish that and have a public dashboard that everyone can take a look at to run it at every commit quite yet, but it's been immensely helpful to get confidence in all the releases.
Yeah, so this kind of connects to another project we've been doing at Google, the Noto project. And the ideas, I think, if I'm right, the idea originally came from one of our engineers, Jungshik Shin, who thought always when we're having fonts, there's something missing, and there's just either one script or one character or something. We're at a place that we can probably commission a whole set of fonts to cover all of Unicode, and then kind of making it kind of homogeneous so it works fine. Whenever you switch scripts, it will still work fine. It's not like a whole weird collection of stuff that maybe you have this, maybe you don't. Kind of the goal is eventually don't even worry that there's something missing. The name Noto, which was kind of came after the idea of the original project, is short for no tofu. Tofu is this small rectangles that you may see or something equivalent that when a character is basically not supported in a font on your system, you don't have no way to support it. So another idea is make it open source so everybody could really use it. What you see at the top is actually a sample of the hieroglyph character, so really everything. So right now we have, based on the script, we have 1 to 7 weights. I mean, the smaller scripts, mostly historical or minority scripts, have just 1 weight, a regular weight. When you go to things like CJK, we actually have 7 weights for the Chinese, Japanese, and Korean characters. We have around more than 90 scripts supported. Right now, it's more than 300 font files, 700 languages that I could confirm. There's probably more. It's very hard to find the writing system of some of the languages after that curve, even if they're written. And right now, it has more than about 600,000 unique glyphs in them. There's sans style and serif style. Again, for some of them, for Arabic, you have 3 styles: the Nasr style, the Kufi style, and the Nastaliq style, which is very important for writing Urdu and other languages of South Asia written in the Arabic script. Even for things like Syriac, which has 3 different styles, there's Eastern, Western, Estrangela Syriac, and there's also color and black and white emoji. What you see at the bottom is actually the same character sequence, the same string, written in the 3 different styles of Syriac. So we kind of try to divide the project into a bulk, kind of 3 different sets, really. A bulk of the work is what we're calling the 0 to 90%, is where most of the actual work was, what we kind of knew we needed to do. And these are some of the examples. We knew there are some differences between Arabic and Persian Urdu, the way some letters or some numbers were supposed to appear. Between Hindi and Marathi, same thing. The various languages written in the Myanmar script had different behaviors, sometimes for their ligatures, sometimes for their letters. We knew we needed vertical forms for basically Japanese and other vertical writing in East Asia. And we knew we needed to support the variation sequences, what we call ideographic variation sequences. What you see on the right side is, if you're too careful, you would notice that there are tiny differences. These are all one Unicode character, but in Japan especially, the small differences matter to some users because these are part of place names or personal names, and they've always been written with this stroke missing, or this stroke change, or this one slightly written differently. Unicode encodes these things as the main character plus a variation selector. And our fonts, for example, support all of these.
Question: it is the same mechanism we're going to use for icon, for emoji, to have, I don't know, race.
So the question was if this is the same mechanism using emoji to express diversity, for example. And not exactly. It's similar.
But not great.
No, yeah, it's actually, for emoji, we have 5 special characters that are only used for that purpose. Here we have lots of characters, and they don't mean the same thing. Basically, the exact sequence matters. Yeah. This ideograph plus this variation selector results in this. As opposed to in emoji, the variation is always a light face, for example, or a darker face.
Well, in emoji, we have variation selector for selecting color versus black and white.
Yeah.
But the skin tone is different characters.
So I'm kind of writing some, these are some examples. I mean, the first 2 lines is an example of how things, for example, differ in Hindi and Nepali. The first 3 things at the left side, those are 3 digits. In Nepal, for historical reasons, they're writing those 3 digits very differently. And this actually came to us kind of very late in the project when we started talking to our Nepali experts. a Googler who actually works in Nepal.
So these are same character, same script.
Yes. So the first two lines are exactly the same character sequence, and same script, same everything. The only difference, they even come from the same font, but in the font we basically have an extra table saying Nepali shapes are different. We actually found these things relatively late in the project because Nepali is heavily under-documented. Google cares about Nepali, and then we found that, for example, these shapes are different. The thing in the middle you have is one of the consonants, which is vastly different. The thing at the right is even more interesting. That's the conjunct. In Hindi, a sequence of two consonants may be written in a conjunct form, but in Nepali, they may want to open it up. So what you may see here is, in the Nepali line, is that the left, this is one consonant, this is the killer of that consonant, and this is the second consonant, which in Hindi basically becomes a conjunct. We also found other things, that there were lots of characters in Unicode that nobody had really implemented right or researched right, but they were important. The example you see at the bottom is kind of a made-up example, but shows some of the features of that we actually needed to research, basically to be able to support properly, first in the fonts, then in the HarfBuzz engine, and then back to fonts again to make sure the fonts use it right.
And then we get to the Noto Nastaliq Urdu, which is my favorite font. Now, Nastaliq, for those of you who don't know, is a style of writing Arabic. What you see on computers and papers in Iran and in Arabic countries is mostly the Nast style, which is much more simplified and monotone, whereas this is really calligraphy. Nastaliq is popular in Iran and Turkey as an art form, but in Urdu they still prefer newspapers to be written in this style. So we commissioned a Nastaliq font from
and not just newspapers, books, everything. This is kind of considered the very important part of the cultural legacy. So yes, you see on web pages and UIs that Nast may be useful, but for lots of things you really want Nastaliq for Urdu.
So we had this being made for over 2 years, and but we never made any public commitment to it or any note of that. We are working on this. And there was this thread on the internet about how Google and Apple and Microsoft and these Western corporations don't care about Nastaliq and they are killing the Urdu script. So we figured that, hey, we have a draft version of the font. We haven't tested it, but just put it out there, break the internet, kind of. And it did break the internet. Well, Internet Explorer, no bugs. That was fantastic. It worked just fine there. With HarfBuzz, shaping was perfect. Firefox had a small glitch, like loading the font would freeze Firefox for 5 seconds. Now, to be fair, that ended up being a bug, parts of HarfBuzz that only Firefox used, and we got that fixed. HP Cortex, I talked about what HP Cortex is, but that broke badly. We fixed that one. Chrome Mac was badly broken. We fixed that by switching Chrome Mac to HarfBuzz. The Cairo graphics library PDF output was broken. We fixed that one. And my font tools-based subset engine was broken. It was taking 9 minutes to subset the font. I optimized it down to 3 seconds. And Uniscribe works kind of well. There's small corner case issue that we discovered we haven't fixed yet or haven't been fixed yet. Cortex and Safari broken badly. It broke Cortex so badly, one of the issues, like it was so broken that Apple got that fixed and released very quickly, but there are other issues that are not fixed, so the font is not really usable in Safari or Cortex. And then Chrome PDF output, Flash InDesign broken, no hope of being fixed.
Yeah, so the poem you see, this is Urdu. Poetry is very important in Urdu. It's kind of one of the things that kind of keeps the language together and connects people to the heritage of their language. And the poem, the line we actually have there is came to us from that original kind of objection. I don't know why he kind of used it, but it's very interesting for what we were doing. We are now providing an open source font. We broke quite a few stuff. The font itself was kind of partially broken too, and then we actually found a lot of things. So it was actually the clay cup, the font. So we can actually just build another and build another. Yeah, so these are some of the things that we haven't really kind of done right yet, and we're trying to figure out how to do. There are ideas about any of these. So cantillation marks, or for example, these things are in Vedic, and it seems that you basically need to position them on the center of the syllable. Right now, OpenType doesn't really support it, and there's no way to specify that. So we're trying to get to these like those. In Nastaliq, the way we kind of do our Nastaliq font and everybody else does the Nastaliq font with OpenType technology is we kind of figure out all potential combinations and we try to kind of play with it so things look right. But it's a kind of a very detailed and I would say dirty way to kind of do it. There are ideas around knowing the kind of the graphical shape of the letter forms and then trying to move them around so they would feel right. The dots, as you can see, sometimes kind of intersect a bit with the letters. There are ways to figure out, oh, this area is kind of busy. We can move it away from the letter form so the dots are more clear, stuff like that.
So basically the problem with Nastaliq is because it's oblique, we don't really have the infrastructure in OpenType to space it properly. The way you want this to be is a calligraphic script. So you want, so for example, this is absolutely unacceptable, but we wouldn't know any better. You want this to move way into this thing, under the start of the next part, but OpenType just is not sophisticated enough for that.
So what else? Yeah, the other thing is, I mean, there's a lot of combinations from the real world we don't really support, and the example you see there is actually very important. It's the parentheses followed by an O, followed by combining, I forget the name of that thing, tilde, followed by underscore and O, again, combining that. That thing is actually much more common than a lot of the scripts that we think we care about. A lot of the internet cares about displaying these things right, as opposed to displaying Oriya right, which is a language spoken by 30 million people, if not more. So, and there's a lot of unknown requirements we're going to basically find out as we deploy this.
So, we talked about a lot of things. We try to take what Unicode recommends, implement it in OpenType and then in our fonts and then report back to Unicode. We give you some more concrete examples. Now remember, OpenType was designed like 15 years ago. There was not enough implementations of Unicode more sophisticated bits and pieces and typographic finesse of the text rendering on the web or computer. So as we got more and more sophisticated, we found that Unicode has specification of the behavior, but not of the rendering or how the technology. And OpenType is a technology piece, but doesn't quite connect to how to bridge the gap between Unicode and how to implement this part of Unicode. So we ended up having to come up with those connections as we went. For example, these are a bunch of examples I'll show you. So normalization. If you ever had to deal with Unicode, you know that in this case, for example, the two characters on the left side are each encoded in Unicode, and the character on the right side is also encoded in Unicode. And Unicode says these two are equivalent. They should behave the same, no matter which one is in the text, except that your font designer might only implement the one on the left or only the one on the right. And the engine, as a rendering engine, we want to have the same behavior no matter which situation the font implements. So that's something we implemented in HarfBuzz. We try to do the right thing. It kind of works magically. This is another example. Again, we have this is Arabic. On the left side, we have a base character and two combining marks. And you can enter them in the format on the top or the order in the bottom, and they should render the same. We shouldn't get the mark order to reverse.
So the Unicode says these two are canonically equivalent, which are basically means it's the same string, but of course it's not the same string because the order of the characters is different. And there are still kind of software out there that renders them differently.
So I mean, so the division of labor is also nowhere specified. You can say it's the font designer's job to make sure these two render the same, or we prefer to say, well, this is specified by Unicode. There's data files that specify this. We might have them implemented in the shaper such that we don't rely on font designers knowing what they are doing. This is a page from a version of New York Times for optimized for a tablet, and it's actually sending down to the browser the soft hyphen character. So soft hyphen this character, this is an invisible character in Unicode that you can use to say, hey, this is a good place to break the line if you have to. So because browsers don't implement good hyphenation, New York Times decided to send down the soft hyphen character to help the browser. Now, we have three different renderings of the same word, same sequence at the bottom. The left one is using graphite font. If the engine doesn't know about soft hyphen, you render it as a hyphen because that's what's in the font. That's utterly bad. The middle section, that's Uniscribe, it doesn't have that behavior. It does know that soft hyphen shouldn't be rendered by default, but it didn't form the ligature there because there was something in between. Whereas on the right side in HarfBuzz, we know that this character, for rendering purposes, it should be ignored and we do the right thing.
Yeah, so some of the reasons we could do a good job at some of these things is actually we finally had a full stack. We had fonts, we had rendering engines, we had good access to Unicode, we had software that were using it, and for the first time we're actually seeing that somebody needs to solve this problem. This is wrong. We couldn't blame anybody else. It was always ourselves to blame. So we basically figured out the right place to fix everything, as opposed to, this is not our problem, the Fontdesigners should fix it. So this is the other example is kind of we found in Unicode, is digging through Unicode, we found out, okay, Unicode has this character called the fraction slash, and the sequence of characters on the left should basically result in the approximation of pi you see on the right bottom side. In practice, that didn't happen. What you see at the top right is the result of basically Uniscribe rendering the same string is because Uniscribe was thinking maybe this is a higher level thing to try to do this kind of what we call vulgar fractions. And also, there's a mechanism in the font to say, yes, this is the superscript versions of these things used for denominators, for example. But you couldn't really use it unless you ask the higher level thing to do it. What we did,
So basically, OpenType has a mechanism to render this. You have to specifically turn the fraction features on. But it's not clear whose job is it to turn those on. Is it the browser, the client of the text rendering engine, text changing engine? We said no. If you see a fraction slash, it's clear that this is the right thing to do. So upon seeing that character, we turn on the OpenType features that take care of it. So that's this connection between semantics of Unicode characters and OpenType features that we are trying to move to the shaper now.
Yeah, and some of the idea is that advanced typography is for everybody, and your text should just work, as opposed to, yeah, this text is supposed to do that, but then you also need to do this additional stuff.
We also do some more things. For example, there's also two examples that we don't do yet, but we have thought about it. For example, Unicode says if a zero-width joiner appears between two base characters, it should encourage ligation. Now, OpenType has this feature for discretionary ligatures. Those are ligatures that are turned off by default, but the user should be able to turn them on. Now, it's easy to see how the zero-width joiner should activate that feature. So that's something that we haven't done yet, but I think that's something I want to do because it just makes sense. No break space, another interesting Unicode character, is a space for all purposes except that for line breaking purposes, you can't break after it. So from a rendering point of view, it should render exactly like the space character. Now, there are two problems. If we do treat it like the space character all the time, it might break sequences with certain fonts because Unicode suggests that if you want to show a combining mark in isolation, place it on top of a no-break space. Now, if the font handles that, but the rendering engine treats the no-break space like a space, we break that situation. If you don't handle it and the font doesn't have no-break space, then that's also broken. So it's one of those situations that we need to look into the font, see which behavior matches the expectation better and do that. These are just a few examples. There's many more Unicode characters that you can kind of improve their behavior if you hook them up to OpenType and shaping directly. This is another example. So now, okay, we connect, like we get it. OpenType should do some of the Unicode stuff, but now, even when things are supposedly very well specified, we kept finding that Uniscript does things that we didn't expect, and then we have to go fix it. The sequence here on the right, the image is an Arabic word, right to left. The blue part is a base character. The red is a combining character. And in this particular font, when the combining character is present, the font designer decides that they want to add that green extension just for it to look less crowded. So it adds that glyph there, but I mean, if you just implement what's in the OpenType spec, after this transformation, you expect the mark to go on top of the green segment because that now is before the mark, but then Uniscript implements it that way. So there's a lot of these kind of things that you have to go see exactly how Uniscript implements things that they are nowhere in the spec or other implementations. And then combining marks, originally they were like before OpenType days, there was no this advanced positioning and things. So if you had a Latin font and it had combining characters, Uniscript took care of like positioning the mark on the base and then removing any advanced width, so things worked. As they started adding Arabic, Hebrew, Myanmar, these other scripts, that got in the way. So they moved the mechanism into the font, so the font can say which marks get a 0 advance and which ones don't. And then that was also not problematic. So for Myanmar, they changed that. For Indic, Hangul, they do not do anything. So we ended up with these like 4 different behaviors for the same concept that we have to apply to different scripts based on just people reporting different behavior.
And this is not specified, right? This is like...
No, none of this.
Yeah.
Yes. So after this, like with Roozbeh, we had more of these sessions where we found that as Noto fonts came in, we found that we still have differences with Uniscript because we were mostly testing with the Microsoft Windows fonts. Noto was designed by other people, use different concepts. So we would sit down, get this sequence of 3 characters that behave differently. You study it fully, try to understand what Uniscript is doing, and then update our engine to do that. And then more of those and more of those. We kept fixing
these
things.
are kind of git commit messages that we basically try to explain everything that so future people would be able to understand.
And so, for example, here, the command here is what we would use to see what's going on, like what does our shaper do with it. So after every time we fix things, I now have a small shell script that records this. What it does is it takes a font, subsets it to only the character in the test, and stores the font subset and the test sequence and the expected output into our test suite so we don't lose it again.
So what we kind of figured out is we now need to make sure these things are available to everybody, basically because we found certain things that are needed of the languages and the scripts that we want to basically interoperate this text between everybody else on the world. It's not like everybody is forever is going to be on Chrome OSs and Android phones. There are so many different platforms in the world. We want to be able to send this to everybody, receive the text from them, rendering the same way, stuff like that. So we actually started to document a lot of these things for Unicode to get into the Unicode standard. The samples you see are, I guess, either things actually done by Behdad or with both of us together, is various things that we tried to do right, and then we figured out either Unicode is limited or doesn't have some of the information, so we kind of tried to pull that into Unicode. For example, one of the good examples here is we found that Mongolian script is actually very much like Arabic in the way it does shaping. So although Arabic in Unicode had data about every character and how it joins to previous and next letters, Mongolian didn't. So we actually pushed Unicode to do that, or we asked them to clarify. The last one is actually very important, is basically the provisional Indic properties we talked about that we had based HarfBuzz on. We found that this was extremely useful. But then Behdad's early research and then my later research into these things, we had found several issues. We found certain things needed to be moved around, certain classes need to be split, and we basically suggested that to Unicode, and they took that over.
So basically, this is like data files published by Unicode, but historically, Unicode didn't want to get too involved or close at all to render it. They definitely didn't want to be involved with any particular technology like OpenType. So this was data that was a lot of data never tested heavily. And as we started driving our engine users, we started to figure out inconsistencies and incompleteness. And Roozbeh took over extending and maintaining that with other engineers.
Yeah, this kind of official kind of project down there, the link is there. This is kind of the thing that feeds into Unicode every release now, where I basically maintain all the properties needed for rendering, both like the script extensions is a mechanism that says this character is shared between these 5 scripts, for example. You need to know how to, when you kind of try to slice your text into different scripts to pass it to different fonts to render. And the Indic properties are basically what's used for everything. There was something else there. Yeah. Could you go back? Sorry. Yeah. This is another example that basically one of the stuff we found. We found that, for example, Unicode specification of the Burmese language for Myanmar script was incomplete. This is the word Taj Mahal. For some reason, Unicode thought that this combination is impossible. So this, for example, made it down to Unicode.
So to recap, 10 years ago, really, we didn't have a lot of stuff going on these days. So for a font designer, there was OpenType, which was a Microsoft solution to the shaping problem, and Unisquare was the only implementation that mattered. And there was Cortex on. Cortex was the library, well, the Atsui Cortex, the Apple equivalent of these technologies that implemented AAT, not OpenType, on the Apple platform. So there were system fonts that were supposed to work with one technology, and as a font developer, well, most font developers also only cared about the Windows platform. So you had one implementation to work with. But these days, with web fonts, we can't make those assumptions anymore. I mean, what's a web font good for if you get different rendering on different platforms? And then there's this Japanese, Korean, Indic layout requirements from W3C now trying to push more typographic features of different scripts to the web, and then again, there's no clear boundary, no clear specification of does this thing belong into the font, or into the shaping engine, or into the browser, or the author, the web page author. So we are just starting to get into real typography, and the boundaries are even less clear. HP Cortex. So in the past year, so after converting Chrome on Windows to use HarfBuzz, and we got like a 4-time speed up, we wanted to do the same on the Mac and get rid of all the other implementation, remove 2 layers of abstractions. The only problem was AAT, as I said, the technology that Apple uses and the system fonts on Apple use, we didn't have any implementation for that. So we thought, well, we have this Cortex backend in HarfBuzz that just calls it Cortex for shaping, and we can use that for AAT fonts and use HarfBuzz itself for OpenType. So this piece of code, we enabled it on Chrome Mac, and it's less than 3% of the HarfBuzz code base. It caused like over 90% of the bugs. We kept getting bugs, crashes, you name it, on the Chrome Mac Arabic fonts or other things, because this piece of code, I just wrote it as for testing, and there were so many corner cases that we had not considered, and all of the other things, normalization, mark order, those things wouldn't work. So we kept getting like more and more bugs on this. And then Graphite 2 again is another technology, not OpenType, not AAT. I stick this up.
Yeah, so this is basically at the same Unicode conference that we presented an early version of these. I think a couple of talks after us, we were sitting, and now Microsoft were presenting, and they were talks what they're calling the universal shaping engine. And the word, as you can see, and they kind of subtitle post-tofu area, it was also a kind of a reference to our Noto fonts. This is now Do
you want to step back to the April?
Maybe you
so last April, a year ago in April, we organized a meeting for OpenType experts across the industry to think about what's the future of OpenType shaping, because we figured that for the next tens of scripts coming into Unicode, we don't want to develop like shapers for each of them. And we have been using this data-driven approach, and we brought it up with engineers from Microsoft and Apple and Adobe and OpenType experts, and we had a full week of brainstorming and sharing ideas, and then everyone agreed that having a kind of a meta shaper or a generic shaper that is data driven by the Unicode data would be really useful and helpful. And then we separated with having this plan of working on such a thing, but it never happened. We were all busy. And then 6 months later, we were at the Unicode conference presenting this talk. And then a couple sessions after us, Andrew Glass, the Microsoft PM or engineer working on shaping, and John Hudson, an OpenType Fontdesigners expert, had this session called Shaping in the Post-tofu era.
Yes, so what basically happened is that, very similar to the idea of HarfBuzz being data-driven, again, we had kind of discussed it with them, they had switched to now a Unicode data-driven shaping engine and tried to generalize everything. The example you see here is from the Soyombo script, which Unicode hasn't implemented yet even, but they basically use it as an example of trying to really get the very complicated edge cases right, to see if they can use something very universal, and with a good font designer, they can get something to do everything. The goal here is similar to what we had in HarfBuzz, is when a new script gets encoded in Unicode, nobody needs to go research it again. The data is there. We make sure we do the data right. This is now a collaboration between basically me and Andrew Glass and a couple of other people to get that data exactly right. And now it feeds into both the Microsoft engine, which is, I think, is going to be in Windows 10, and our engine.
Yeah, so basically what they did after, we worked with Andrew and others on this, and in February they announced this new shaper called the Universal Shaping Engine in Windows 10. And this image, that's the expertise that Andrew Glass brings to the table. Like Roozbeh and I couldn't go make this. This is a generalized graphic cluster structure that supposedly will cover every script that will be encoded in Unicode.
Every script in South or Southeast Asia, kind of the traditional Indic scripts based on Brahmi.
And then new spec has more grammars. They are more complicated, but it's the same idea. So what's going to happen on the HarfBuzz side, Jonathan Q and I are going to meet again in July for a week, sit down and implement the Universal Shaper and test it against the Microsoft implementation. And the idea is that this is hopefully the last time we have to do this, because this one is designed to be extensible.
And of course, we're almost like 95% there already. We kind of discovered this by ourselves.
All the framework and infrastructure, we just need to adjust it. So what we learned? Well, we learned that shaping is hard. No, it's really, really hard. But, well, to be honest, it's only hard to do it interoperably. Otherwise, we have 3 implementations already. And since you didn't fall asleep, I'm going to play a clip for you.
Profiles and yours really stuck out. Oh.
You hear? No? What can I do?
I read a lot of profiles, and yours really stuck out.
Oh, thanks. Suzanne did the artwork, and I wrote the copy. She wanted to go with the Helvetica font, but I insisted on Courier to make it easier to read. We compromised with Times New Roman.
Honey, they don't want to hear that.
Why? Everyone likes fonts. I like fonts. Wingdings are my favorite.
Do you have any questions you would like to ask us?
Okay, and that's the end of our slide.
So do you have any question you want to ask us?
So I see 2 basic trends here. One direction, you try to get every script readable at all. And on the other hand, you're trying to get up scripts that are already readable, but to give higher quality typography. And on that side, I mean, I really like the table of all the different variants for the Japanese character. In the Noto effort, are you also going, are you already, or are there any plans to support the different typographic traditions within Europe, where you have one single Unicode code point that traditionally types it quite differently in different typesetting traditions?
I'm very sorry, we can't talk about that publicly.
Anybody else?
No, but we already, like, our LGC Latin fund already has, like, Romanian versus Serbian forms. Yeah. So?
Do you know whether Microsoft has tried to address the issue of kerning in Nastaliq? You showed the example where
yes.
you
So especially in Nastalig, I don't know any effort on the Microsoft front. Graphite. I saw
was
that
going
they
to
have
ask about Graphite and whether they handled that or not.
Yeah, they're adding new features to the Graphite engine. They have a talk submitted for the next Unicode conference about Arabic positioning system. Now, my problem with Graphite is in wanting to improve shaping, they threw out all of OpenType and invented everything.
Yeah,
reinvented
it's
everything.
completely.
So, well, I have my own ideas about how to do this on top of OpenType. And monotype, or the most common like typesetting system in Pakistan is called InPage, and it uses an OpenType font. Then on top of that does some fitting. So I have ideas along those lines, but I don't know Microsoft working on it.
Okay.
This is maybe a little off the topic, but Unicode arts continue to be important in certain segments of the internet. Can you tell us a little bit more about the challenges there that you listed? One of the challenges, Unicode arts.
Yeah, the kind of a short answer is we don't know enough about these things. So this is kind of the in a way from the way, I mean, some of us have been brought up. We've been brought up with typography and kind of high-level text. And this is stuff that some people kind of tried and figure out, and then basically drew some stuff that works and now is very popular. It's in a funny way, nobody appears to be focused on it really well these days. We are back into the traditional typography that books and good magazines kind of come from, and you want to do those right. And then somebody really needs to look at these things carefully, find out what really matters. In practice, what I kind of think matters is almost 100% compatibility between platforms, in a way that if somebody writes some sequence of these things and they display in a certain way on Windows or a Mac, theoretically you display it right, otherwise you've lost interoperability. You're showing something totally different. In practice, that's impossible because all these people, kind of these platforms, disagree about how to do things right.
Now, without knowing much about the inside of Microsoft, my understanding was that for Windows 8, for what they called universal applications or something like that, the ones that you can buy in the store, run it on a tablet and on a desktop, they have a new text engine.
Right.
From what I know, is that I don't know, is that a Uniscribe ++, or is that a primitive version of the universal shaping you mentioned?
No, that's direct right. And from Windows 8 on, Uniscribe is a C# library that wraps direct right. But our understanding is like the actual engine just went from Uniscribe to direct right. So we keep referring to it as Uniscribe, but it's same implementation, just moved into a new library.
Yeah, so what I heard from Microsoft people is not exactly the same. It's a very similar implementation. Again, there are bugs in one, but not the other. But they basically kind of have two shaping engines which are almost the same. And there are some bugs in one that they haven't fixed in the other, and vice versa.
Yeah, this isn't a well-formed question, but I was wondering if you could speak a little bit to the interplay between sort of the line layout engine and sort of higher level sort of fitting engines that sit on top of it, the ones that do line break and maybe have to customize the behavior because they're doing justification, and maybe they don't want optional ligatures if they're doing justification, or they do.
Right.
Can you speak a little bit to how that will get addressed in web fonts and things like that?
So that's excellent question. The reason I ended up focusing HarfBuzz on the shaping side is because it was very easy to come up with the API there that I can only care about the lower level and clients only not to have to care about it. So, but now, especially in the web space, there's a lot more you need to do on top. For example, things like small caps or italics or bold. Like, why is the small caps implemented as an OpenType feature, but italics is typically implemented as a different font? The user doesn't care. Like, the browser now has to go see if is small caps implemented in this font, or do I have to just resize the font and do my synthesized small caps? Same thing, line breaking again, hyphenation, those things, higher level. Justification is much harder. OpenType has a table for justification. No one implemented it because it's just not possible to implement it. It was written without an implementation, as far as I know. So we have talked about all these things for years. We just have not got there yet.
Yeah, and we are, I think a lot of everybody's kind of moving there. I think Chrome recently has done some of the rewriting of their system, and they're thinking better about this. Android in Lollipop has been kind of improving on some of these things. I mean, so it's a long-term plan, and I think everybody's thinking about it. Again, I think the people who had platforms earlier out, I mean, Microsoft, for example, and Apple are a bit ahead in kind of knowing some of this stuff. At the same time, they get a lot of regressions too. So in new versions, some of these things go back. Everybody's trying to figure it right. For Latin, everybody thinks they know how to do it. For lots of other scripts, the specifications are in the air. As Behdad talked about, the JL-Rec, the Japanese layout requirements, for example, that's been out there. Nobody has really implemented it completely, especially in the kind of the Western software world.
So that's Japanese is an interesting example because the only Japanese implementations of proper typography are InDesign or other systems implemented in Japan or for the Japanese market, and they are pre-OpenType. And so there is no OpenType Japanese spec. So that's like hand-coded behavior. Now we don't have a good solution in OpenType for Japanese. But on the plus side, the more positive answer is we just got to the point that HarfBuzz is used like all platforms Chrome, all platforms Firefox, all of Linux,
Android.
So we now go build things on top of it and say, okay, this is how you do line breaking and font fallback with like HarfBuzz, and this is how you do a script like this. So we are just getting started on building those higher levels.
Anybody else?
Last question.
Thank you. Oh, okay.
Yeah. What's the biggest problem that you are now working on solving?
You ask unanswerable questions, but I think Behdad can answer some of this, yeah.
So yeah, on my side, I've been now busy on the font production side of things. Noto, it's already hundreds of fonts. We are obviously thinking about expanding that. We have more revisions coming in, so we have been working on like on the how to create better fonts, how to optimize fonts better for different platforms. For web fonts, we care about size. For Android, we care about size. For Windows, we care about hinting. For Mac, we care about, I don't know, OpenType implementation. So we are working on like improving our font pipeline.
That's really fantastic. Because that means that after years of having problems with substandard, not good enough renderers and shapers and all this, you have managed to make all of that so good that the font fights themselves became the problem.
Well,
it's pretty awesome.
That's the result of all of this being open source, so we can fix them in the proper place. Yeah.
Very true. Again, this is all about when we do every piece of the puzzle, then you find this other thing that's now broken, and this other thing you can polish. Yes, that's been the very good thing that came out of this, having a full stack experience.
Okay.
Thank you, everybody.
Everyone. Thanks, Eric.
Yes, so